Hello Legacy students, Marsh here. So today we're going to look at Pythagorean Theorem, the most important information ever created. Basically, you've heard of Pythagorean Theorem before. It focuses only on right triangles. So Pythagorean Theorem only works with a right triangle. Don't try this in obtuse or any of those kinds. So, right triangle. That's what that's going to look like. It's the legs. There's two legs and then a hypotenuse. What you know in symbols, technically what it is leg squared plus leg squared equals hypotenuse squared. However, you have probably seen it as a squared plus b squared equals c squared, aka leg of A, leg of B, and a hypotenuse of C is probably how you have seen it in your math career already to this date. So, how do we use the Pythagorean Theorem? Ultimately, what you do is to find a side of a right triangle when you already have two of those sides. So I know 4 and 3. Notice, guys, if I look across from the right angle, the point of my right angle is going to point at my hypotenuse. So my x is the hypotenuse. So what I like to do is I like to label my A and my B. A, B. Now notice A and B could be flip-flop. That does not matter. But C always has to be your hypotenuse. Then I will plug it in to a squared plus b squared equals c squared, the Pythagorean theorem. So a 2 squared plus 3 squared, because that's b, equals c, which is x squared. So I got 4 squared, that's 16, plus 3 squared, that's 9, equals x squared. Basically, I'm going to add, and then you're always going to be square rooting at the end. So square root of 25, that is just 5. So x can equal 5, aka the hypotenuse length is 5. Let's try the first example here. So I got A, B, and C. Let's figure out what those guys are. Especially C is the most important. So A, it looks like we have a 6 here. B is 10. C, across from the right angle, is x. So let's go ahead and plug that in. A squared plus b squared equals c squared. So I got 6 squared plus 10 squared equals x squared. So that's just me putting and substituting A, B, and C into Pythagorean theorem. Let's square pieces now. So 6 squared, that's 36, plus 10 squared, that's 100. And I'm equal to x squared. Let's add now. 36 plus 100. That is 136 equals x squared. Let's square root both sides. Since we have reviewed how to simplify a square root of 136, let's break him down. So biggest perfect square, aka 4, 9, 16, 25, that can go into 136. 4 goes in, that's 34. 34 does not have another 4 in it. No. So square root of 4 is 2. So it looks like x equals 2 times the square root of 34 for a final answer. Let's try the second example here. So notice, guys, I've got my right angle right in the corner here. Whoops. Got a right angle right here. So if I draw my line pointing, looks like 15 is C. So C is 15. Looks like A is 8 and B is X. So notice, guys, this one's going to be a little different compared to example 1. Let's plug in. So we got 8 squared plus x squared equals 15 squared, because C is 15. So I got 64 plus x squared equals, what's 15 squared? AKA 15 times 15. Let me do that quick. 225. There we go. I need x squared alone, so I'm going to subtract 64, because otherwise I can't square root. X squared equals 225 minus 64. That's another number I don't know. That would be 161. Square root both sides. Simplifying 161. 4 doesn't work. 9, no. 6. You know what? I think that is a prime number. Square root of 161 seems to be the final answer. Sometimes they do not simplify all the way down. That's okay. That happens. So we also need to talk about Pythagorean triple. Basically, there are a set of 3 whole numbers that work in the Pythagorean theorem. Now, you're probably asking, okay, what does it mean to be a whole number? That means that they have to be positive numbers and they have to be a number. No fractions, no square roots, no nothing. It has to be normal that work in the Pythagorean theorem. So let's check here. 1, 2, and the square root of 5. Notice, guys, this is not a whole number. It has a square root. This is not a Pythagorean triple. Otherwise, though, if you would plug it in, it actually would work. But it is not a Pythagorean triple based on a whole number. So then I got 9, 16, and 20. Let's check to see if it works in the Pythagorean theorem. So 9 squared plus 16 squared equals 20 squared. Now, your largest side is going to be your hypotenuse. That's just the way it's going to work. So 9 squared, that's 81. 16 squared, I believe that to be 256. Yes. Equals 20 squared, that is 400. So if I look at this, 7, 6 plus 1, 5 plus 8, that's 13. So 337 equals 400. Not good. That is not a Pythagorean triple. It doesn't work in the equation. Let's check the next one. 4, 4, and 16. So 4 squared plus 4 squared equals 16 squared. So I got 16 plus 16 equals 256. 32 equals 256. Not happening. Let's try D. So I got 9 squared plus 12 squared equals 15 squared. So 9 times 9, that's 81. 12 times 12, 144. 15 times 15, 225. And I got 5. Oh, look at that. 81 plus 144, that is 225. Thus, I have found my Pythagorean triple, 9, 12, and 15. Now, there's many sets of Pythagorean triples that work. Sometimes you'll find that they are multiples of one another. However, there is quite a few. There's infinite many. Lots of them. Now, why would we need to use the Pythagorean theorem? Sometimes you want to find the area of a triangle. Or basically you want to find the height of the triangle. Because remember, the area of a triangle is 1/2 times the base times my height. Now notice, guys, I don't know what the height of this triangle is. I don't know the up and down height, and that's what I need. But if I look at this one little triangle right here, I have a hypotenuse of 12. I have a base of 4, and I can find the other leg. So I can name him X. Let's go x squared plus 4 squared equals 12 squared, using my A of x, B is 4, and C is 12. So I got x squared plus 16 equals 144. Let's subtract 16, shall we, to get x squared alone. So 144 minus 16, that is 128. I got to square root both sides. Ooh, square root of 128. You know what? 64 times 2 is 128. So square root of 64, square root of 2. 64 is just good old 8. So it'd be 8 square root of 2 for my x. Which tells me that the height of this triangle is 8 square root of 2, which means I can now find the area of my triangle. So area equals 1/2 times my base, which of the full triangle is 8 inches, times my height, which is 8 square root of 2. Don't worry, that's square root. Don't worry about him. He's fine. Let's just multiply all the numbers on the outside. So 1/2 times 8, half of 8, that's 4, times 8, 32, and then I just attach the square root of 2. So my triangle has an area of 32 times the square root of 2 inches squared. Now you're going to find that Pythagorean theorem is used a lot in like architecture and also just building and carpentry. It's a very common thing used in real life situations. And we'll look at some of the real life situations in class. But that's the end of this video. See you later, Sabers.